Now, in dealing with exponential functions, we have two types of things that can happen: growth and decay. Now, how can I tell whether it grows or decays just by looking at the function? Well, if you look at this first one over here, this stuff, what you see is that if b is bigger than 1, you know this is going to be an increasing. So that means that as x gets bigger, the b to the x is going to get bigger over time. So this is going to be increased, so we're going to grow. If b is less than 1 and bigger than 0, then over time it's going to decrease by a certain amount. So you can tell by just looking at the b if it's written in this form. Now, because we know that exponentials have this property where 1 over b is b to the minus 1, a lot of times they write these exponential equations this way, where the b is always positive, and the number that may sit in front of it, like in this example 1, if it's positive, it's growth, and if it's negative, it's decay. Now, this number here doesn't just have to be any number, it could be, or negative 1, it just has to be a negative, and sometimes they'll use the letter k in there. So, like, you could put a positive k in there, and that would give you growth if it's positive, negative, decay. And so that's how you can tell just by looking at the equations. All right, so let's look at number 26. And we're supposed to find an exponential function that passes through all this data. Now, what they're really getting at here is that when you have some sort of exponential function, what you know is that if you take two values that are 1 unit apart, you get just b. The a's divide out, the b divides in, leaving just b. So if I look at the data I have here, the y values would be 20 divided by 10, which is 2. And then I had to have 40 divided by 20, which is 2, and 80 divided by 40, which is 2. So we know just by looking at this that b is 2. So now what I want to do is I want to plug in f of x is equal to a times 2 to the x. So because I know that piece. What I then would like to do is plug in a 1, because that's the first value there. Get a times 2 to the 1 is equal to 10. Right? Divide the 2 over and I get a is equal to 5. I get the equation f of x is equal to 5 times 2 to the x. All right. A scientist begins with 100 milligrams of radioactive substance. So our initial amount, let's call it A, equals 0. Now it says that it decays exponentially. So what do we know? Let's use this version of exponential like this. And so what I know is that f of x equals 100 b to the x equals 100 when x equals 0, right? Because that's where we're starting with. Now if I plug in 35 equals 100 times b to the 35, this is half to equal 50. So I get b to the 35 is equal to 1/2, or b is equal to the 1/2 all to the 1 over 35, or the 35th root of 1/2. All right, so that gives me this function of x is equal to 100, 1/2 to the 1 over 35, all to the x, and then I just plug in 54, and then I plug that into my calculator, and I get 34.32 milligrams, like that.